Okay, so for this first question, we've got the base b on both of these logarithms. That should be an indicator that you're going to do a change of base, because then we can get rid of b completely from the equation. Because b is an unknown, we're not going to find it with two unknowns. Let's get rid of b. Using this half, we can rewrite it into this half. So this will give us log base 2 of x equals 7. Then we can rewrite it using the definition of the logarithm. The base is 2, so x is equal to 2 to the 7th, which is 128. The next question is a little trickier, but we see we've got logs in two different bases, so we want them in the same base. So this one is in base 8, so let's put this one into base 8. This will give us 9 log base 8 of x minus log base 8 of 8 over log base 8 of x equals 0. So then at that point we can, we want to get rid of denominators usually. We can also simplify here. So log base 8 of 8 is 1. Log base 8 of 8 is 1. That's going to give us a 1 there. Let's divide by 9, bring that one down here, move that term across, and then we get log base 8 of x all squared. Yeah, so I'm going to multiply through by this term here, the log base 8 of x, squaring this one. I'm going to divide by the 9, giving us 1 over 9. I'm going to add 1 over 9 to both sides, so I get to this.
So you multiply the denominator first, right?
Yeah, to cancel denominators. Usually one of the first steps in equation solving.
So we put the logs on the same side, so how do you move the 9 to the other log?
So this will simplify to 1 over log base 8 of x.
Yeah.
And times by that to cancel it there, and it squares that one.
Oh.
I then divide by 9 to give us 1 over 9. I add 1 over 9, move it to the other side. And then I'm going to take a square root, which gives me log base 8 of x is equal to plus and minus 1 over 3. So rearranging now, this tells us that x is equal to x is equal to 8 to the plus minus 1 over 3. The cube root of 8 is 2, so, and the cube root of 8 and then to the minus, so this will give us this.
Why is it plus minus?
The root.
When you square root both sides of an equation, you have to consider two possible solutions. In fact, that was one area where a few people really struggled in the test. There was one area that I saw some people struggling in the test. And it's based from IM2, obviously. What is the square root of 16?
Just 4.
Some people think the square root of 16 is plus minus 4. This is not the case. The square root of 16 is only 4. It is not plus minus 4. Now, if f squared equals 9, that implies that x is equal to plus minus the square root of 9. That's different. We have to consider two solutions when we square root both sides of an equation. But the square root function on its own only produces one value. And you see this when you graph it. If we were to graph the square root function, it's going to look like this. So when we put 16 in, we're going to get only 4 out. There aren't two solutions. It's an extra layer of logic when you square root both sides of an equation. You have to consider two possibilities.
So if the logarithm aggregate like more than two solutions?
It's a function. For every function, there's one output. But if it's involved in an equation in some way, other things can introduce other reasons and things. But the log function on its own is a function, like everything, and it only has one answer.
When you say square root of 16, does So it's not plus or minus 4, it's 4, right? Because it's a function as we remember. But if we're doing algebraic and we were to square root 16, we still have to do this one. So it's at the top.
When you take an equation and you apply the function square root of x on both sides, when you apply the root of plus and minus, when you apply the root on both sides of an equation, an even root, you add a plus and minus. If you have the square root already, you're not applying the square root on both sides of an equation.
Mr. Where did the log go in the last few steps?
We rewrote it using the definition of the logarithm, which says that the logarithm of base 8 of x is the number we need to raise 8 by in order to get x. So from the definition of the logarithm. I'm just going to do this one for you. So we've got e to the kt, where t is equal to 1380. This has to halve. This has to be half its original value. So then we take natural logarithms of both sides. So we get ln minus ln of 2 is equal to 1380k. So k is equal to 1380. Sorry, k is equal to minus ln2 over 1380.
Why is it the minus?
Why is it minus?
Yeah, because it's over 1 minus the. Because anything over 1 is the negative power. The negative gets pulled out.
It's neat. I would accept ln and a half, but minus ln2 is better.
So how did you get 1,280 in the numerator?
Because t is equal to 1,380.
Don't you with like t over the half-life?
And how would you let
Yeah,
t?
that's why.
But we know the value of t.
Yeah, I was just confused. I didn't know what t was.
What's the
Time.
It's always time.
That's how.
Yeah, I know. Yeah, but I was just confused.
So it's
What's
not.
t?
Okay.
T is time. Time is 1380.
Use time with you.
You only put it over the half-life if the base is 2.
We're counting that.
You've not got a base of 2, you've got a base of e. So you have to compensate to find out what the appropriate value of k is. Sorry, if the base is a half.
We can do that.
Okay, let's have a go at this next question. So here on this one, we can use the product property of logs to begin with to write this as log base 12 of x minus 1 times x minus 2. And we can see at this point, we got to get rid of the log base 12. So on the right hand side, you can always turn any number into a log base anything, using the basic idea that log base 12 of 12 is going to be 1. If that number isn't 1, if it's 3, then you write 3 log base 12 of 12 and then bring the 3 inside. You can always turn any number into a logarithm in any base using this trick. So now, as we have a logarithm base 12 on both sides, we can apply the function f of x is equal to 12 to the x. This is the inverse function of log base 12. When you're solving equations, you never actually do anything other than apply a function on both sides. You just pick the right function. If you want to get rid of, in the previous question, we wanted to divide through by a 9. So we're applying the function x over 9 to both sides of the equation. This cancels. If you want to move something from the left-hand side to the right by adding it, say you want to move a 1 to the other side, you apply the function x minus 1 both sides. You can't count, something I saw in the test at this point that caused some consternation was some people tried to cancel this. So this is x squared minus 3x plus 2. Some people tried to cancel this like this. Is this okay?
No, divided by 1.
Already one. No, it is, but it's already like
Yeah. This is fine.
You can
No, but it just-
just
it's
divide
not
by
like
one.
dividing by one.
But it's that you didn't
But
do anything.
aren't you just
Yeah, but it-
move the 12?
Wait, no, I don't want the right answer. At this point, I want to show some of the horrors I have to put up with. This was fine. So I've not really done anything. I'm still back with a 1 on the right hand side, and I've divided by 1 here, which doesn't change anything. That's perfectly fine. But what horrors I would see is this.
Oh, no.
You can't divide and cancel a function with a function. You can only get rid of a function with its inverse function. You can't cancel functions. This basically implies that the student feels that the log of 12, no, the log base 12 of is a mathematical concept on its own. You can't take log base 12 of and then not finish the sentence off. Log base 12 doesn't mean anything. Log base 12 is a function. You can only have log base 12 of x. Then you're putting something into the function. You can't just cancel a function on both sides. You can't cancel sine on both sides. Oh, sine as cancel. Or, no, sorry, on a fraction.
Like in the case where there is a base on the top and the bottom, you can't
No, you can't just cancel the logarithm. You can't just cancel the logarithm. What we can do, let's go back a little bit. Here at this point is the correct way to cancel it. So here at this point, we can apply this inverse function to both sides. And the inverse function, because we only have one log of one thing on one side, log in the same base of one thing on the other side, we can cancel using 12 to the x. Because then it's the same as if you have both sides of a square and square root both sides. You apply the function root x. If you have a square root on one side and a normal term on the other, you can apply the function x squared on both sides to cancel the root x, cancelling the function. So here at this point, we cancel the function, which gives us x squared minus 3x plus 2 is equal to 12. So this gives us x squared minus 3x minus 10 equals 0. And we factor to be x minus 5, x plus 2. And then we can use the zero product property to say that x equals 5 or x equals minus 2. Whenever you get to your solutions, you must get all the solutions. One thing you should always do is copy down the question exactly as the question is given. Always start solving your math by copying down the question exactly as the question is given. This helps reduce transcription errors, but also it helps at this point, because it's at this point we have to refer back to the original equation to look for extraneous solutions. So x equal to minus 2, you can very quickly see will produce the log base 12 of minus 3. And you can't take the log of a negative number. So you can just write something like no logs of negative numbers.
Do we have to write this?
You have to give a reason when you're throwing away a solution. Always give a reason when throwing away a solution.
The log cannot have negative input afterwards.
Yeah. Yeah, anything as long as it understands that you're using the right property or the right concept.
Sir, but you can't have a negative number as the base of the log function.
Can't have that either.
But you can have it if you square it. So if you have negative 5 squared, or like negative 5.
But they don't have negative 5 squared.
But negative 5 cubed, it equals
You can't have negative 5 cubed
what? It's equals to negative.
because it equals a negative. It can't be
You can't have negative in either.
Logarithm can't be a
I
negative.
know, but I think that's still the solution. It's not in the logarithm.
Well, we're not talking about the base being negative here in this one.
Yeah.
We're talking about the input being negative.
But if the base is negative.
The base can never be negative. The input can never be negative.
So if you have like negative 5.
Have a go at trying to write something down. I'll come over and have a look at it.
Wait, if you had, like we were saying, if log to base minus 5.
Can't have that.
No, look, if you had that,
Can't have that.
you just can't. Like, it doesn't matter.
You can't, because any input that isn't an integer value is going to cause a problem. Maybe it's not defined. So if you're taking like the square, if you put in like a half, you're taking the square root of a negative value. That's why the base can't be negative.
If you're solving that, you roll x squared. You don't have a negative solution.
If it's, no, you can for that one. So if it's log base 12 of x squared, a solution of x equals to minus 2 is fine because it won't cause any problems in the original equation. Because the original equation is squared. It depends. So this one comes up a good one. If we have the equation ln of x squared, and we have 2 ln of x, are these the same original equation?
No, because they need this.
No, it's the same. No, it is the same. It's the same.
It's not the why is it not the same?
It is the same.
Because the first one is squared.
Let's say x is equal to minus 2. This is good for one of them and not the other.
It's working.
It's the power of c, no?
Order of precedence. You put
No, because the two is
input
inside the bracket.
the input comes first.
So if the.
So we've been doing this whole time is wrong. If the 2 is outside the bracket, you would have 2 LNS, right?
It doesn't matter if it's inside or outside.
No, it doesn't matter if it's inside or outside.
Yeah. No, but two
Sure.
and-
So what we've been doing this whole time is wrong.
Yeah, you just
I
told
don't
us
know.
the wrong code.
A lot of what you do is wrong. I try and correct that as best I can. So here on this one, the original equation, minus 2 is going to work here because you're going to be finding ln of 4. But here you'll find the ln of minus 2 and then times it by 2, which is not good.
So for the reasoning, could you also say like,
Always write down the original equation.
yeah, but I'm saying for the reasoning when you're excluding -2, could you also abstract it like x minus 1 is greater than 0,
Yeah.
x minus 2 is greater than
It's the
0?
same. It's the same. The reason behind you doing that is you're avoiding negative input to a logarithm.
So doesn't that mean you can't use the power property when solving?
You can. You can.
No, but also for all.
You can do it when solving.
But then you only get one of the solutions.
It depends what the original equation is. Not the
Like
solution.
ln as x
It
squared.
depends what the original equation is and what comes
That
out.
one is
That one is
What I'm saying is, check your answers in the original equation.
2 L and it's the same as L and S equals 2, right? Because the power property is not the power, you put it back.
Yeah.
Put it to the L and S to the power of 2. Right,
They're the same.
they're the same. So is it the way not to solve it?
No.
Find whether
It's just showing that because they equal each other, a negative number can always. Yeah, so this works, just that's why it's cute, negative.
Okay, let's move on. How are we doing for time? Let's move on a little bit from that. Next topic up after the break, we're back to trigonometry. Trigonometric functions, trigonometric identities, and small trigonometric equations. So I would recommend, if you want, over the break, to go to Khan Academy, trigonometric identities. You may write these down. Trigonometric identities, transformations of trigonometric functions. I'm hoping that will be easy at this point. We've done so many transformations now on this course, and trigonometric equations.
Mister, is the semester exam gonna be both semesters or just this semester?
Sir, you know,
But I think there's both
Wait. Let's have a go at solving the equations on the board. You see,
x is equal to 50.
half of the people in this room have got a clue how to do this.
this one.
The first one is 50.
No, you just do
This is so easy. I can pull up. Sorry, do you want me to pull up your semester exam and show you this question?
I hate this message.
Okay, now let's have a go at solving the question. I believe you should see trigonometry and solving trigonometric equations every 6 months until you master it properly. Yes, I am like a Jedi master.
Do you recommend
So this first one, we need to get rid of the sine function on both sides first. How do we get rid of the sine function? We take the arcsine function on both sides. When we take the arcsine function, in the same way that when we take the square root function, we have the plus minus. When we take the well, I can't remember the plural, the trigonometric. When we take the different arcsine functions, the inverse trigonometric functions, it has extra logic to it as well. So for this one, the first principal solution to this one would be something like maybe minus 30 degrees. I think it's minus 30.
Yes, we said 330.
But 330 also. And then 210.
Okay, this is the principal solution. But we have to add some more logic. We have to say, well, n plus 360 degrees, because any rotations of this on the unit circle. So if we're looking at a unit circle, we have a half here, so minus 30 is there, and any rotations of this will land in the same place. Sorry, can I ask you to quieten down? But we also have extra logic in this one, in that any others, you also get a set of solutions at 180 minus the principal solution. So 180 minus 30 degrees plus n 360. That's going to be at 210. That's going to be at 210. It's over here. It's over
Can you
here.
just add it when n equals to 1/2 and have the answer in here?
No. So now what we need to do is we need to divide through by 3. So this gives us x is equal to minus 10 degrees plus n 120 degrees, or x is equal to 70 degrees plus n 120 degrees. At this point, I'd like to ask, what are the 4 smallest positive solutions to this equation? What are the 4 smallest positive solutions? Alex.
70 degrees, 210 degrees. Yeah.
No, 110.
Wrong.
And then
That was 130.
yeah, then 210. Oh yeah, you have 190. 190.
Oh, that.
And then 200.
230.
210.
Not 240.
No, it's 200.
Yeah, 200. No,
100.
So is it 200?
You're adding one
Oh,
point.
yeah.
These are the first 4 smallest positive solutions.
How do we do this? And is there a formula?
Sorry, can I have quiet, please?
How do we do this? Is there a
So,
formula?
yeah, we're using these 2 formulas. So we're going to start off with this one. N is equal to 0. So that would give us 70. Next, and then we're going to alternate always between these 2. So now we're going to take this one. We're going to take n equal to 1. So we get minus 10 plus 120 is 110. Next one comes from this. N equals 1. 120 plus 70 equals 190. And then 2. So 2 times 120 is 240. Minus 10, 230. And so on.
So why can't you say negative 10? Because I said positive.
I said positive.
Oh,
What's there a way to cancel the calculation?
You have to know how to do it without. On the semester exam, the main mistake I saw for this equation was people did this horror show.
You cry?
I needed to eat a lot of chocolate as I was marking this. I was feeling very low. Do we see what the issue is? What's the student thinks they can do, and what's the issue there?
They could just casually take the number out of a function, like as if it was just like regular.
Yeah, so they're taking the number inside the function outside by dividing through by. Hassan, stop touching him.
So you took my pen cup now. Is it my pen cup? So what's the treat and then it's
Can you boys not keep touching each other in class?
Two boys from TV.